My name is Arnav Tiwari, and this is my Lab 3 video on black holes. This lab was split into two parts, where in part 1 we analyzed the motion of a star to find the mass of a black hole using glow script, and in part 2 we simulated a spaceship's trajectory moving between a planet and its moon, trying to get a figure-8 trajectory by adjusting initial velocity values. This lab will explore the effects of Newton's second law and its relationship to momentum. To give you a brief preview of the results, the mass that I got was around 1.68 times 10 to the 34th kilograms, while I was successfully able to get the figure-8 trajectory. The fundamental principles used in this lab are the force of gravitation, with F equals g m times m over r squared, as well as Newton's second law, with a system's change in momentum is proportional to the net force acting on it. Looking at the code for part 1 and trying to find the mass of the black hole, we have this calculation loop here in which we calculate the momentums as the mass times the velocities. We then calculate the change in velocities and the change in momentum by subtracting the final minus initial values. And then we calculate dp dt, which is again just change in momentum over change in time, which is we made that equivalent to our net force. And then over here I calculated the parallel and perpendicular components to see the change in direction as well as the change in magnitude of speed. And yeah, that's about it. This was the outcome of the code. As you can see, it's a star moving around in orbit of a black hole, and the masses are given here at the end of the loop at around 1.68 times 10 to the 34th. For part 2, the code is again a calculation or a calculation loop in which we find the net forces on the moon, the net forces on the spaceship, and then we apply Newton's second law to update the position, and finally we use these positions to try to get a figure-8 trajectory around the black hole. So here is what I had for my outcome of part 2, and as you can see, it does resemble a figure-8 somewhat. I'm not 100% sure if this is correct, but this is what I could do with my code. And yeah, as I played around with the initial velocity values, that is what I ended up getting. Some possible errors in my lab was that there could have been some rounding errors. Since this is a simulation, it's never going to be able to represent the real world. So there's always going to be slight errors with approximation, and using trial and error for velocity values isn't the most accurate, so there could have been some more accurate values that I could have used. So what is the difference between force and momentum rate of change? Net force, pretty much we have to know every outside force exerting something on an object, and for the latter, rate of change of momentum, only need to know the change in the system's velocity. And for the last question, what would be needed to model the full system? We'd have to consider other forces like gravitation interactions between all the objects, such as the black hole, the stars, the planets, the moons, and the spaceship. In conclusion, I was successfully able to estimate the black hole's mass and experimented with and was able to get the figure-8 orbit for my spaceship. And further refinement with the initial conditions could give a more stable trajectory, making my lab more accurate.